So the vocab here. So we talked about relative maximum and relative minimum on Friday. And those are just basically any of the turning points of the graph. Okay? So when you guys see a graph, and let's say that it goes like this, this graph has no maximum, but it still has a relative maximum right here. Anything that's a turning point that behaves like a maximum or a minimum would in a parabola is a relative maximum or minimum. Okay? For the factor theorem, the factors are just telling us much like a quadratic. So what you guys want to do is transfer your quadratic knowledge, but now if there's just like more of them. So when we factor something, these things are going to kind of go together right here. When we get our factors, it's easy to get our zeros or our x-intercepts, right? Okay, so our factors are going to tell us how many real zeros there are in the problem. A zero can have a multiplicity, okay? For example, remember in quadratics, when we factor them, we kind of expect them to pass the x-axis twice. But think about like this quadratic here. How many times does this quadratic hit the x-axis? Once, okay? So it only has 1 0 at x equals 2. However, that's considered a multiple zero. The reason it's considered a multiple zero is we would just list it once. However, the behavior at that zero is different because it came from a factor that has a power bigger than 1. Okay, meaning you were using this zero more than one time. Okay? And then the multiplicity means how many times were you using it. So when we find this zero, x equals 2, we would say that this zero has a multiplicity of 2. Okay? And what that means is it wasn't just in a factor where it showed up one time, it showed up 2 times. So that doesn't really mean that much as far as listing it. You don't have to list it twice. However, it will mean something different about how the graph behaves there. Okay? So, for example, just kind of like preview. If we had x minus 1 and x minus 2, what would be the zeros of this quadratic? 1 and 2. And if we were going to sketch that parabola, we know this from the last unit, right? We would expect this parabola to be concave up, and we would expect it to cross at 1 and 2, and it would cross completely through there, right? However, if we take this equation that we wrote here, the x minus 2 squared, okay, we only expect it to hit at 2, and does it cross all the way through the axis at 2? No. Instead, the parabola would come down, it would hit at 2, but that would also be the turning point where it turned around, right? So the behavior is different if the power is 1 than if the power is 2 on a 0. You know if the power is 2 that you expect this kind of behavior, like the vertex of the quadratic hitting the x-axis, where if the power is 1, like these ones here, you expect it to cross all the way through. Is that okay with everybody? Okay. All right, and then we're just continuing our work on factoring. I know that these have a higher power than 2, but remember when you guys factor, the first thing you should do is look for the greatest common factor. And in this case, all the terms have x. So if we take that out, we get this, and x squared plus x minus 12 should be something that you should be able to factor on your own with whichever method you use. So it would factor as x plus 4 times x minus 3. So that's the completely factored form of that polynomial. Same idea here with this one. If I factor out x, I'm left with x squared minus 144. And how does x squared minus 144 factor? Good. Okay, yeah, difference of squares, right? No middle term because it canceled out. So it's like those conjugates. It's x plus 12 times x minus 12. Okay, and that would be the factored form. Yes. Mm-hmm. Yeah. So did you guys understand Zen's question? She's just like reiterating the fact that multiplicity just means the power that it's being used because you would have that many of those factors. And so it means that thing was the zero this many times because it had that many of those factors. Okay? Any questions on anything from here? All right, so then we're going to use these ideas to sketch. So this is the part about homework 2 that you guys were talking about. Hopefully you guys could get through like the factoring part of it. That's not that new. If not, hopefully they gave you the hint of how to do so, okay? And then we're going to go ahead and look at finding equations of graphs. I'm going to pull down the screen. Scroll this up. Okay, so to find an equation for each of these graphs, okay, the zeros are going to help us figure it out, okay, because they can build factors for us. And if we can build factors, we can multiply together the factors and get the equation, all right? So for this first one right here, I know this is asking for something else. Are you guys good with the relative minimums and maximums based on what we did yesterday, that just estimating the turning points, okay? And so I'm going to kind of skip this part because we spent a lot of time on it yesterday and talked about it, or Friday, sorry, yesterday in school days for me. And then we're just going to I'm going to write the equations right here, but you guys can just write them next to the graph, okay? All right, so I look at this graph, okay? Do we think it has an odd degree or an even degree, first of all, based on the end behaviors? So graph A, should the degree of the function be odd or even? Jesus? Okay, so even means that they end like a quadratic. Think about a quadratic. Ends in the same direction, okay? But see how this end's coming down and that one's going up? So this ends in different directions, so it won't be like a quadratic. It won't have that even degree feature, so it'll actually be odd degree. Is that okay? So I expect odd in my answer, okay? And then I'm going to try and build it again by using factors, because those are easiest for me to pick off of this graph because I can see the places where it hits the x-axis. So what's one of my zeros? What's one of the places that the graph crosses the x-axis? Jenna? Good, so -1. And that one goes straight through the x-axis at -1, right? So we would expect, oops, not like that. We would expect x plus 1 to be a factor. That's how I would get a 0 of -1. And I would expect the power on it just to be 1 because it behaves like it does from the ones I studied in quadratics. When the power is just 1, it crosses all the way through. Okay. What's another 0 of this function? 2. Okay. So I expect another factor to be x minus 2. Does it cross all the way through the x-axis at 2? No. It behaves like the vertex of a quadratic, right? What had to happen to the factor in order to get that behavior with a quadratic? Yeah, it had to be the only 0 of the quadratic, which meant it had to have a power of 2. So anytime you see that behavior, that's telling you that this has a power of 2, okay? There aren't any complex or imaginary solutions because I've covered 3 solutions essentially. -1 and 2, but twice would be 2, right? So there's the 3 solutions. That's the maximum amount of things that can happen in a cubic. And when I multiply these out, I'll get something of degree 3. The only thing that would then be missing here is whatever value makes this graph actually cross through the other points. Now, when we're graphing, we're just sketching, but this one's been sketched for us. And so what we want to do is we want to use another point that we can clearly see on the graph. I see that it hits the y-axis at 4, okay? Right? So the point 0, 4 is a point on this graph. So I'm just going to plug in. Remember how we talked about using points that we know something crosses through whenever we're missing a piece of key information? So this means that y should be 4 when x is 0. And then that can help me find the a value, okay? So all this stuff over here, -2 squared would be 4 times 1. So this would be 4a equals 4. So a would be 1, okay? So my answer or my equation for this graph is this. You can leave it in this form unless it explicitly asks for standard form. If it asks for standard form, what would we do? It's not in standard form right now. It's in a factored form. Jenna? Yeah, multiply it out. Okay, so use the distributive property, you'd multiply it out, and then you'd get all the terms separated, and it'd be in standard form. Okay? All right, somebody that didn't give us information from the last example, when we look at the graph in part B, do we expect the final answer to have even degree or odd degree? Odd degree. Okay? Can somebody give me a 0 from that graph? Sophia? Good. So -3 is a 0, which means I expect there to be a factor of x plus 3, and it goes straight through, so I would only expect to use that to the first power. Okay? Somebody give me another 0 that we see up here. Alex? 0. So x or x minus 0, for those of you who doesn't sit well right away with you, to have x. And again, it goes straight through it, so I would only expect that 0 to be used to the first power. Okay? And then what else? Claire? 4. So then I would expect a factor of x minus 4, again, only being used to the first power. And again, I haven't accounted for how high or how low the curves are, so there could be some coefficient here. Now, I can't use 0, 0 in this case because it was already one of the zeros. So if you use a point that's already the 0, it's just going to have everything cancel out on every side. You're not going to find anything out about the a value. So I want to find a place that I think I can see it clearly cross. Do you guys want to pick one? No? -1, 4? Say 1. Okay, so if we use -1, 4, so if I use 4 for y when x is -1, so I'm plugging in -1 for the x values. So then this becomes -5 times -1, which is +5, times 2, which is 10. So this is just 10a equals 4, which would give me that a is equal to 2/5. Okay, so my final answer is an a value of 2/5, and then these factors, a factor of x, x plus 3, and x minus 4. You don't have to write the x how I did. That's more simplified than x minus 0, and normally when it's just x, they would write it at the beginning after, and then the larger factors after. Okay. Again, if they want it in standard form, you'd have to multiply that out. Okay? Yes, Jenna? Yeah, or it doesn't even have to be a clear turning point. It just has to be a clear point it crosses through on the graph. Okay? So like where you can read a point off the graph and you can say, oh, I see it exactly crosses right here. Okay? Otherwise, you're like estimating a 0.5 or something, and that's not going to work out well. Okay? Are we okay with writing equations from the sketches of the graph? That we're using the zeros to come up with factors, okay? And that we're putting the factors together to get the equation. And then we have to work on finding that value. Yes? So the 2/5 was the a. So it goes here, essentially, to finish our equation. And then x minus 0 is not normally, if you guys left it like that, it wouldn't mark it wrong. But like if you check the solution in the back of the book written in simplest factored form, they would just call this x. And they usually write the factor that's x that's not as long as the other factors. They usually write the shorter factors first and then the longer one. That's all. Okay? All right, so we should be able to write them from a picture, and then we should also be able to write them from information. I actually think now that you guys have done it from the picture, writing it from the information will be simpler. And the one thing about the information is unless they give you a point that it crosses through, you don't know. So you're just writing an equation that works. So you actually don't have to deal with the a value in those circumstances. You just have to deal with the factors unless they say and crosses through this very specific point. Okay? So they tell us in this first example, zeros of 1, -1, and 4. Okay? So because of 1, we'd have x minus 1. Because of -1, we'd have x plus 1. And because of 4, we'd have x minus 4. Okay? I'm going to be lazy. In our quartic function for you guys, I'm not going to multiply it out and write it in standard form. If it asks you to, do. I'm going to do this one for you guys to make sure that you guys know how to multiply out correctly, because some people have been struggling with just some of the operations. So when you multiply something out, you need to pick two things and multiply them together, and then multiply them by the third thing. Okay? So let's say I pick these two. I don't actually think these are the easiest two to pick, but here's what I get when I multiply them out. Okay, if you don't get that in one step, that's fine. You multiply it out on the side of your paper, combine the like terms, and you get that. And then remember when you're multiplying something out now, that when you distribute, every term from the first factor needs to multiply every term from the second factor. So x has to go through and multiply all of these. And so does negative 1. Okay. So this is our polynomial in standard form once we've combined some like terms. So my final answer is going to be that y equals x cubed and then negative 4x squared when I combine the two like terms, and then negative 1x and plus 4. Okay. So if it asks for it in standard form, like we mentioned before, you just need to multiply it out. There's an example of how to multiply it out. Okay. I took standard form off of this one because I don't want us to spend our class time multiplying together binomials. I do want you guys to get practice with it. So if it says it in the homework, because some people aren't doing it correctly, like I've been giving you guys a lot of those, find f of a minus 3. They've been on at least every other weekly review and on your last test and on this last test, and some people still are not doing it correctly with the order of operations. When you guys see something that says, something squared, you can't just square each piece. If there's addition and subtraction in there, you got to write them out and actually FOIL them just like you do right here. Okay? So in this one here, we would have y equals, what would one of my factors be based on the zeros? Then? Okay, so that one's giving me the 0 of 1, and that 0 is listed twice here, which means its multiplicity is 2, so we're going to square that factor. What's another factor that would be in this polynomial? Good. For the negative 1, I would get that value of x from setting x plus 1 equal to 0. And what else would be a factor here? And x minus 4. Okay. And then just like before, if we were going to multiply it out in standard form, we would start taking a couple of pieces. This would not be x squared plus 1 or minus 1. This would be x minus 1 times x minus 1. It would actually end up being x squared minus 2x plus 1 when you FOIL it out. Okay? So make sure that you guys are squaring things appropriately when you do that. Any questions about writing equations in general? Yeah, Jenna. Well, it should match with what you get at the end. So like if, we'll get a little more complicated later, but if they tell me only 2 zeros, there needs to be another 0 in there in order to make it a cubic. Okay? And then we'll talk later about like complex solutions too and how you could put those in there. But so what should happen is if you don't match the degree that they're saying at the end, then you either didn't use a multiplicity correctly or you didn't have enough factors and you needed to put in another factor because they only gave you some of them or something like that. Is that okay? So that should correspond with the degree that you get at the end for the polynomial. Okay. Any other questions about writing equations? Yeah, Zen.
So when you do like not factor, but like do the square for the x minus 1, should you just distribute like regular for the other?
Yeah. And so it's going to get super like long. So when you do x minus 1 squared, when you set it out and multiply it, you actually get this. Okay? And then you have an option here. You can multiply these two together and then have two really big things to multiply together, or you can just keep going in this order, just like we did before. So this would be like x cubed minus 2x squared plus x squared minus 2x plus 1. And then I can condense it a little bit. But that still has to be multiplied then by x plus 4, and then I distribute each one of those through. Is that okay? Any other questions that you guys have on this part of it? No? All right. Okay. So we're going to go ahead and get the graphs fairly quickly. So either on your calculator real quick, and I'm going to do the same and just put them up here, or if you prefer to like use Desmos on your phone or something like that, that's fine. We're just going to get the graphs. And let me give you the equations. Okay, for your cubic, just going to graph x plus 1 to the third power. Okay, if we multiply that out, that'll be a cubic. Okay. And for our quartic, we'll do x minus 2 squared and x plus 2 squared. And again, I'm going to get them up here too so you guys can see that just. We're just sketching, so. All right, and so as far as the notes on comparison, here's the things that I just want you guys to look at. We're just kind of reiterating some things we did before. End behaviors you should know, so if you want to make some notes about that. Yeah, right. So just use the little caret button. So it's right next to, it's right below the clear button on the right side. So see the yellow arrow keys and then clear and then little caret and then whatever power you want. So when you guys look at these, make any notes you want about end behavior compared to degree, but also we want to talk about our factors. So any factor that's to the first power, we talked about how the 0 goes kind of straight through the x-axis. Then in our quartic that we put up here, we used factors that had a second power on them, right? And so each one behaved how we've seen things behave when it's a second power. So every time you have a factor to the second power, when it hits that 0, we expect, like a quadratic with its vertex at that point, okay? That it doesn't go through the axis straight like a line, but instead it curves right when it hits it, okay? And then I want you guys to look at our cubic, okay? So a cubic can go like this, right? We've seen it before, it can turn around. This one doesn't technically turn around, and look at how it goes through the axis. It does go through and continue on the other side, but it doesn't go straight through like our things did before. It starts to look like it's going to turn around, and then it doesn't, okay? So factors that have a second power, like a quadratic, behave like a quadratic at their 0. Factors that have a third power behave like a cubic at their 0. They go to turn around, and then they don't quite turn around. It looks like it's going to be a vertex, then it's not, okay? So it doesn't ever actually turn back the other way, but it curves while it goes through. So when you get to things like the 4th power, 5th power, 6th power, because they have similar behaviors, like you guys saw with your cubic and your quintic and stuff like that, we just have to know these main behaviors. That we either go through the axis, just like normal, no curving. If it's squared, we hit it and turn around, and if it's cubed, we curve through it like this, okay? So if we're going to sketch a quadratic polynomial function with zeros at 3 and -3, so quadratic means like a parabola, right? And it has these two zeros, it's going straight through and straight through. Each of those zeros just has a multiplicity of 1. Nothing special about them, okay? It's going through the x-axis along the curve. I'll give you guys a couple of minutes because when I change the screen, it's going to, thing that it's going to tell us to graph is going to give us multiplicities of zeros, okay? So here it says sketch a cubic polynomial function with zeros at 3, 3, and -3. Okay, so this tells me There's just one 0 marked at positive 3 this time. There's still a 0 marked at negative 3. Same information as I had previously, but this time it's a cubic polynomial, okay? So remember how cubics behave. They didn't tell us if it has a positive or negative lead coefficient, so you could technically draw this two ways depending on how you interpreted it. Let's say I assume it's, negative to positive, okay? So I expect behavior here to go down here and behavior at this end to go up here, okay? This 0 at negative 3 had multiplicity of 1. It should cross straight through. But the 0 at positive 3 has multiplicity of 2. How should it behave at that 0? Then? Yeah, it should be a turning point at that 0, okay? So I'm going to go through this one, but at this one, I'm going to make sure it makes a turning point. And so there's something that's a cubic, different directions with the end behavior. But with those two zeros, I'm able to make it look like a cubic because one of the zeros had multiplicity of 2 and became like a turning point. Okay? Any questions on why this sketch is different than the previous one we did? Okay, and I knew to do that because the multiplicity here and because it should match up like a cubic. The other one was quadratic. There weren't any multiplicities in the zeros, so I need to pay attention to those things. Okay? All right, so take 30 seconds in your group. Okay, write something down right here for yourself. Okay, I've tried to kind of summarize it for you, but I want you guys to summarize it for yourselves, and I'll just kind of travel around each group to answer any questions. Explain how the multiplicity of a 0 affects how the graph behaves at those zeros. So how does having multiplicity affect what you're going to draw when you sketch it? Okay,